Hello and welcome to the Chapter 9, Section 4, Practice Selected Problems. We've got changes in dimensions here again. This has been sort of a tough section for us, so I wanted to give you a little additional support in this section. This is a required video, so you want to make sure that the notes that you're taking here, they can go on the back of your 9.4 practice sheet. We're looking here at the original and at the new triangle. There are going to be two different types of problems that you're going to see mainly in this section. The two different types of problems are going to be problems where they tell you how the dimensions have changed. So that problem might say the dimensions of the triangle have been multiplied by 6. And then there are going to be the type of problems like this where they show you the two figures and you have to establish what the relationship is or what that change is. So for instance, between this original and this new problem on the right, we can see that to get from 3 to 12, we would multiply by 4. And to get from 4 to 16, we would multiply by 4. So the change in dimension for this problem is multiplying by 4. I'm going to go to the next slide, and I'm going to be using the same example. So here we are on the second slide, and we've got the same problem that we were working with over there. So remember what we determined by looking at the side lengths. To 3 to 12, we multiplied by 4. And to get from 4 to 16, we multiplied by 4. So we can tell that the side lengths have been multiplied by 4. So let's go ahead and write that, because that's the first thing you want to find out. So as you can see here, I've written down the first piece of information. And again, this example needs to go on the back of your 9.4 practice sheet. So what I've written down here is that the side lengths have been multiplied by 4. So now that I found out the relationship between the two figures, now I'm going to ask myself, are we going to be looking at area or perimeter? So let's go ahead and take a look at that. So as you can see here, I've written describe the change in area. And what I'm saying is describe the change from the original figure to the new figure in the area. So without even calculating the area, I want to leave the calculations out for a second. Without even calculating the area, because you know the relationship, you should be able to state how this affects the overall area. And I'm going to show you how. It's a skeleton response, just like we talked about in class. So as you can see, I've written the part of the explanation here. It says since the side lengths were multiplied by 4. Remember up here with the white, we found out they were multiplied by 4. We are going to square the 4 to get 16. So since they were multiplied by 4, we're going to square 4 to get 16. And now the last piece. Okay, so as you can see, I went ahead and wrote the last piece. It says to find the new area, you're going to multiply the original area by 16. So this is the word, these are the words, this is the theory, this is the rule. So this is what you need to be able to understand about all the problems when you change the dimensions, how it affects the area. It doesn't matter if it's a triangle, a rectangle, a hexagon, it doesn't matter what the shape is, because they're going to give you shapes like hexagons that you don't know how to find the area. So you have to be able to know the rule and how to apply it even when you can't calculate it the long way. Now we're going to go on to the next slide, again using the exact same example, and what we're going to do is put the numbers with it. Now we're actually going to prove it using the numbers. So the first part of understanding this section is really understanding the theory behind it. The theory is, since the side lengths were multiplied by 4, you want to square 4 to get 16, and then to find the new area, you multiply the original area by 16. So let's go ahead and check that out with the numbers now. So now we're going to go ahead and look at the original triangle here, and we've got a base of 4. So that formula we're going to start with is area equals base times height divided by 2. And now we're just going to plug that in. Area equals base of 4 times 3 divided by 2. So that's going to give us an area of 4 times 3 is 12, divided by 2 is 6. And we'll just, we'll call these centimeters, I suppose. Centimeters squared. Okay, so now we have that area. Now let's go and calculate this area. So now we have area, again, equals base times height divided by 2. Notice I'm starting with the formula each time. You need to as well. Okay, so right here we have a base of 16 times a height of 12 divided by 2. And for time's sake, I'm just going to go ahead and give you the answer to the 16 times 12 divided by 2. But I guess we could actually even cross-simplify it to make it a little easier. So we can, but I don't want to actually, let me go back. I don't want to do that because I just want you to understand the idea. So 16 times 12 gives you get 192. And you're going to divide that by 2. And that's going to give you 96. And remember, I gave you the centimeter square. So it'll give you 96 square centimeters. Okay, so now what you've done is you've put the numbers with it. So I'm going to just remind you of the theory again. So we're starting right here with the theory piece. It says since the side lengths were multiplied by 4, we're going to square the 4 to get 16. To find the new area, multiply the original area by 16. So let's see if that theory worked out. So what we should be able to do to justify, this is the big part. So what we should be able to do to justify is we should be able to say, okay, between here and here, we had to multiply by 4. Then right here, let me go back. Okay, so I put the side lengths were multiplied by 4, which is what we found out on the other page, the previous slide right here. So in the white, we said since side lengths have been multiplied by 4, then we said, okay, 4 squared is 16, and I'm going to flash back here. If you notice in pink, I have since the side lengths were multiplied by 4, square the 4 to get 16, okay? So that's what we've done here in pink. And then that last piece says to find the new area, multiply the original area by 16. So now let's justify that. So now this original area, which was 6, should be able to be multiplied by 16, which came from here, and all of that should equal 96. So now we need to just do that really quickly right here. So we need to take 16, multiply it by 6, and we get 96. And so our justification here, all right, so as you can see, I've written my worded justification here. It says, since the side lengths were multiplied by 4, and 4 squared is 16, multiply the original area of 6 by 16 to get the new area of 96. And basically, this whole problem is your justification. You are justifying it like this. So this is how you would work out the area problem. And you need to be able to understand how to describe each one of these steps. So now we're going to look at the same figure, but we're going to use we're going to talk about perimeter. I say perimeter for last because it's the easier connection or relationship to make between the two. Now you'll notice in this problem you see the hypotenuse labeled. The hypotenuse is that long line. You'll see that it's labeled with 20 and 5. So I've put that there because now we're dealing with perimeter. You have to understand though that in a problem, in the problems that you're seeing, they're going to give you the shape looking like this from the beginning. So you have to know that the hypotenuse, again, which is right here, you have to know that that doesn't apply to anything when you're using, when you're working out the area. The only time you need the hypotenuse length is when you are working with the perimeter. So now I'm just going to give you the word rundown of how you would establish the relationship between the original and the new figure for perimeter. Okay, so what I've written here is since the side lengths are multiplied by 4, the new perimeter is found by multiplying the original perimeter by 4. That's it. It's a direct connection. It's a direct relationship. So there is no squaring. You don't have to worry about that. That's really the only difference between the two. So now let's go ahead and do the math for those. So the original perimeter, and remember, perimeter of a triangle, you just add the sides up. So the original perimeter, okay, so the original perimeter here we got was 12 centimeters. And now let's look at the new perimeter. So the new perimeter here is 48 centimeters. And you should be able to now multiply. Remember what you got up here, the times 4. So now the last piece, the justify, is basically right here. You're basically saying that 12 times 4 is in fact 48. So the new perimeter is going to be 48 centimeters, which is 4 times the original perimeter, which was 12. Okay, so as promised, I did say that I would go ahead and go over one of the problems here. Actually, I'm going to go over 2 of them. So it says, describe the change in perimeter. Okay, so that's my first keyword here, perimeter, from figure A to figure B. All right, so now you can see figure A and figure B. So let's look and see. This is one of those problems where they give you the figure itself. So you need to do those arrow lines that I do so that you can establish a relationship. So let's look. Between 5 to 10, we needed to multiply by 2. Between 6 and 12, it's multiplied by 2. Between 5 and 10, it's multiplied by 2. And between 12 and 24, it's multiplied by 2. Now notice that the height doesn't change, and that's okay. That is okay. So what you're looking at here is you have established the relationship that everything, the dimensions, are multiplied by 2. So let's go ahead and write. So the first piece is we're going to go ahead and write the whole thing in words. Okay, so you can see that I've written out my information here in words, and I would like you to do the same thing. And it says, since the side lengths are multiplied by 2, the new perimeter will be 2 times the original perimeter. So now we've written it in words. That's the first piece. You need to have that right there. And now we're going to go ahead and do the math so that we can prove it and justify it. So now, just as I've asked you to do before, I've set up an original perimeter side and a new perimeter side. So now, let's go ahead and calculate the original perimeter. Keep in mind, perimeter is going to only deal with the things that are on the outside of the figure, because this would be like the fence around your yard, not the area inside. So that 4 inches that's in the middle here becomes irrelevant. You don't need that right now. So let's go ahead and see if we can calculate the original perimeter. So for the original figure, we have 6 plus 5 plus 12 plus 5. So we're going to write that. So we get 28 inches. Now for the new perimeter, we're going to do the same thing. We're going to get 12 plus 10 plus 24 plus 10. And we got that from here, 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 and here. And as you can see, we get 56 inches. So now our justify piece, the part that we are unfamiliar with, or the part that's new to us, is going to be this. So my justification looks like this. Since the new perimeter will be 2 times the original perimeter equals 28, and 28 times 2 equals 56, which was my new perimeter, in fact, right here. So now you are finished with the perimeter. All right, so for number 4, it says to describe the change in area from figure C to figure D. So here is figure C and here is figure D. So let's go ahead and talk in words about what that's going to look like. So first you need to establish the relationship between C and D. So that's step 1, establish the relationship. So let's go ahead and see if we can do that. Okay, so I'm going to line up the sides here. I'm going to see that to get from 8 to 40, I can multiply by 5. So let's go ahead and write that off to the side here. And to get from 9 to 45, I also multiply by 5. And to get from 7 to 35, I also multiply by 5. So look at that. I think we've established the relationship is to multiply by 5. Okay, so as you can see, I've written this out in words. I said since the side lengths are multiplied by 5, and 5 squared is 25, notice I changed my color there to blue or aqua so that you could see that that was another step. The new area will be 25 times the original area. So now we need to show the math for that. Okay, so as you can see, I've set up both sides, the original area and the new area, and I've started each of the problems out with the formula, base times height divided by 2. So now we're just going to plug in the information so that we can justify or prove our response. So as you can see, I went ahead and found the base, which is right here, 9 meters, times the height, which was 6 meters, and I went ahead and plugged that in. 9 times 6 is 54, divided by 2 gives me 27 inches squared. I'm sorry, meters squared. I need to change that. Oh, it was meters squared. I just couldn't read my own writing. So it's 27 meters squared. Now on to figure D, which is the new area. Okay, now as you can see here on the right for figure D, where it says new area, I plugged in the 45, which we got from right here, times the 30, which I got from right here, the base times the height, and then divided it by 2. Now when you're doing this on your end, you can definitely cross-simplify out the 2 and the 30, and I would suggest that you do that so that your numbers are a little smaller and you've cut out one step. But just for continuity, I wanted to make sure that you could see exactly what I was doing with each step. So now comes the fun part. We have the 27 meters squared of figure C, and we have 675 meters squared of figure D. Now remember our theory above. Since the side lengths are multiplied by 5, and 5 squared is 25, the new area will be 25 times the original area. So the way that we test or justify to make sure that we are correct is going to be to multiply out the 27, which was our original, times the 25, which we got from squaring up here, and we should anticipate getting the 675, which is right here. And as you can tell, right down here is what we got, the 675. So for this problem, for the area problem, as long as you have the words first, like I've written right here where I just pointed to an arrow, and you have the original and the new set up exactly like this, and then I can see your work, which is right here, that work for the justification, that's to make sure that your answer is correct. That's plenty of information. And I'm asking that you refer back to your examples when you get stuck and you need to complete 9.4 practice, which you should have been taking these notes on the back of, and then you should have been working the 2 problems out on the front of. And then you want to also correct textbook page 701, because we will be going over that tomorrow, and then we're going to move on to section 9.5. I will see you in class. Good luck.